This one is a very interesting one. It says to write an equation of the straight line through 7, 1 that cuts off the least area from the first quadrant and verify that it's minimal. Alright, so you think of what are you trying to optimize? The area. So before we do that, I want you to see what's really happening here. These are all lines over here that are through 7, 1. This first one, you have a lot of area here, and then as the line moves down for the second picture, you get a little less area. If you move down to the third picture, it's even less area. And then you might say, well, why don't we just keep on going all the way? But when you get too far low, then you start to get this, which has an infinite amount of area if it's level. So there is a spot where you shouldn't go any lower on this y-intercept here. Alright, so we're optimizing area is 1/2 x times y, and so we say our constraint. We have to tie x to y somehow. So we go down that road as usual. We use our other information that's given. It's a straight line. It's through the point 7, 1. So here's your line equation. Simplify that down a little bit to here. And then you start realizing, I have this third variable in there, m. I don't know what the slope is. What is the slope? So we realize that what you're really after is the x-intercept, which determines that length, and the y-intercept that determines that length. So really, let's find the x-intercept and the y-intercept. So we go ahead and do that, setting the y by equal to 0. Your x-intercept comes out to be this, and to get the y-intercept, setting x equal to 0, your y-intercept ends up being this. So then you realize your area is just going to be 1/2 x0 times y0. That's really going to be the area. So you substitute the two expressions in for x0 and y0, and this is your optimizing equation now. It's in one variable, and if we minimize that area function as a function of the slope of the line, you're going to have your minimum area. So you do the first derivative, set it equal to 0 as usual. Here's your first derivative. Solve that out, and you end up with plus or minus 1/7. But as you can see in the pictures, all the lines have a negative slope. So we're going to go with this one here, this negative 1/7. And so your line equation that's going to minimize the area is figured out here. And so it finally turns out to be negative 1/7 x plus 2. That's the line. And just to make sure that the negative 1/7 really was the minimum, the slope that created the minimum area, then we have here, over on this side, a double prime. We figured it out, and it's greater than 0 at the point m equals negative 1/7. So it's concave up there. So you have this concave up look, and which establishes that that slope of negative 1/7 really does give you the minimum area. Now if you wanted to find the area, you just plug the slope of negative 1/7 back into the area formula, which is here. this area formula, and that would give you the minimum area actual value.